Hello?
Hello?
Hi, can you hear me okay?
Yep. How's it going?
Good, how are you doing?
Pretty good. Just settling in.
Okay, so I'm gonna try and simulate my regular interview process. But first I wanted to ask you how many years experience you have so I can kind of tailor things towards that.
Sure. So I'm actually a new grad.
Okay.
I guess I'm just preparing for some phone screens and on-sites.
By new grad, do you mean that you graduated college or are you still in school right now?
Oh, I'm doing my final term. I've done a couple of internships before.
Mm-hmm.
So I guess gone through multiple years of doing these interviews. But it's the first time for new grad positions.
Okay, great. Yeah, that sounds good then. Maybe you could just, so usually on phone screens, we'll have like a 5 minute like get to know you thing, but since this is anonymous, we'll keep that short, and then I'll give you a warm up problem, and then after that, it'll be a slightly longer problem. Does that sound okay?
Sure.
Cool. So maybe you could just maybe tell me about the project that you enjoyed working on the most in your undergrad career.
Sure. So there's definitely like a couple that come to mind, but one of the ones where I'd say I definitely liked the result of it the most was this test automation framework that I was working on during one of my internships. I was actually basically it was meant to analyze or look at images and just make sure that there's no regressions in say some rendered content. I was able to bring the actual time for running those from say like over 7 hours to around one, from the realization that most of the operations were network bound because I was sending the images over. So instead, I optimized for the common case that the images were the same by just hashing them and doing the comparison of those.
Cool. And was that your main project throughout the internship?
No, that was just like well, the test automation framework, yes, but the decision to hash it, that was like a couple of days of stuff.
Neat. Okay. All right. So we'll jump into a problem now. Feel free to code this up in any language. So I just pasted it in there. And so the question is that typically in a programming language, you'll have a built-in function to compute the exponent of a number. And instead, we're going to implement that on our own. And so
Okay.
how is the name of the function? And let me know what you're thinking, and we can just get started.
Sure. So just to make sure I understand this, I'm just trying to calculate the final result when I do the exponent of a to the b. So as a naive approach, one of the things I imagine you could do is to just repeatedly multiply the value, right?
Yeah.
So I would just have a, and then I would decrement b every time, and just keep on multiplying that over and over again. Is there really any way I can speed that up? So I'm guessing that division is a valid operator. So if I think about a power, it should work out that the power of say a to the 2 is, or a to the 4 is equivalent to a to the 2 times a to the 2, right?
Yeah.
Is that correct? Yeah, I think that's how it, uh, yeah, it should be multiplied by each other. It's only when you times them that it's plus, right? So yeah. So I should be able to split up my powers into smaller amounts and then say merge them together in the end, right?
Yeah.
So naturally that seems like I want to try and take maybe a recursive approach in order to split them up. One thing that I didn't account for is, or I guess clarify, is are there any constraints or assumptions I'm allowed to make on whether these values are okay, it says they're integers, but whether they're negative, positive, anything like that, non-zero?
They'll be valid integers, but they can be negative or positive.
Okay, got it. So as well as zero, I'm guessing, right?
Yeah.
Okay, so one thing to handle is that I already know it's an edge case that if b is equal to 0, then my result is always 1, right? No matter what the base is. And if I have negative values, how am I handling that? So negative values pretty much means that the final result should end up being a fraction, right? It's pretty much the opposite. Not negative values for A, but negative values for B. And then instead of doing a power, I'm going to be actually doing a division, right?
Yeah.
Trying to remember how this actually works out. So let's say I have 9 and for A, and I have 1/2 for B. That should be the equivalent. That's pretty much the same thing. It gives me 9 because that's 3 because that's the square root.
Oh no, sorry. B is an integer, so it will never be a fraction. Yeah.
Right, I mixed that up. I was supposed to say that this was a negative value.
Yeah.
Oh, okay, right. That means that it's pretty much the exact same as my normal power operation, except now it's 1 over the final result. Which definitely makes this simpler because now I don't have to handle like a fraction in a different case. It ends up being just I check if it's negative. If it is, I can just use a Boolean flag to say that my final result is going to be 1 over my result. Yeah, so that ends up working out. I'm pretty sure the only thing I'd have to account for is even versus odd values of B, but I think we can figure that out as we code. The complexity of this actual thing should end up being, I'm dividing by 2 every time, and then I'm kind of merging together, right? The initial complexity, if I were to just multiply every time, that ends up being big O of B. If I were to just multiply A, B times, but with what I'm doing, am I really saving that many operations? Does it count as, are we counting multiplication operations as constant?
I think as you write out like the series of calculations, like once you code it, I think the complexity will be more obvious to you.
Sure.
But you'll see that how many function calls you make sort of describes the complexity of the function.
Yeah, I was thinking that it would be log B because I'm splitting in half every time and it's a constant merge, but sure, I guess.
Yeah. Log B is right. Yeah, go ahead.
Cool. So that's power of A to the B. We can get to edge cases later on, but the more important thing was the core logic, right? So do we need to have a math.ceil and a math.floor to separate even and odd? Let's just think of the base case first. Say that B is equal to 0, then we return 1. Otherwise, if B is equal to 2, we return A times A. If it's less than or equal to 2, then we just return A times B. Otherwise, we want to split it, right? Then we say that result is equal to power of A, and then B divided by 2 times power of A and B divided by 2. This works out, I'm pretty sure, perfectly fine for when you have even. It's only if the value is odd that you're going to have one value of B missing. So I guess to make it more concrete, if you were to have 3 to the power of 4, make it 2 just for each multiplication. You would start off with doing the power of 2 multiplied by the power of 2, and then you'd hit the base case and you'd return 4, until you'd end up with 16, which is correct for the result. If we were to use 5, now we suddenly have the same thing, right? So the easiest thing to do is to just break this up. And that if B mod 2 is equal to 0, then that our result is going to evenly divide. Otherwise, our result is going to be a bit different. and that I should end up using the seal in this case. So for that.
Sorry, why do you need, or did you say like math.ceiling, or what is the function?
Because what I'm thinking is if I can't divide, 5 by 2, right? Because that'll just give me 2. Instead, I want to do math.ceil, 5 over 2, multiplied by math.floor, which, I mean, I don't need the floor just because it already does the floor by default, right? For an odd case.
Sure, but do you think there's a way you could do it without using math.ceiling? If you think about, so
yeah.
What is different about the odd case versus the even case?
So for the odd case, I have this one extra number left over, right? So I guess the easiest way to think of it is that I could just add 1 afterwards. So I would have, this plus 1, right?
Yeah. Well, so if you think about it in more like math terms, do you need to do pow of a b plus 1, or is there a way you could decompose the exponents?
Yeah, I could definitely make it that it's what is it? Another option is to do b minus 1 so that it's the even case multiplied by a, right?
Yeah.
This is I guess that's going to break it down so that it's odd or even, and then I guess from then on it's always going to be the case that all of my powers all the way to the bottom are going to be even, right? Sure. So I guess we can go with that. And I guess just reasoning about it, when we have 5 as an example, you're going to have, that b mod 2 is not equal to 0. So you're going to have the 2 multiplied by the power of a to the 4, which is, we already reasoned for it, 2 to the 4, we know it's correct. So the final thing I should have to do is account for whether my a or b is negative. So right off the bat, I'm going to say is negative is going to be true if b is less than 0, else false, and then we're just going to set b to being absolute of b. For setting a negative, the math should already take care of it, so we don't really have to account for that. All we should have to do is just have the 1 over versus non 1 over. So return result if or return 1 over result negative, else result. And I think I have to convert this into a fraction, so that doesn't do integer division.
Okay.
Yeah. So is it okay if I run this on some cases?
Yeah, sure. Could you try to enumerate all your cases before you run the code?
Yeah, so the main cases that I cared about were the ones that I talked about, where I have, say, b is even, b is odd, and then b is negative, even or odd. For all negative cases, the code should turn out so that it's equivalent to the positive case, except for what we have on line 34 and line 21. We've reasoned about the 2 to the 4, which gave us 16, and we're just going to see that, our negative was false if we had 2 to the 4, so we'll just return that 16. Mainly because I think when we talked about the base case, we have, we're hitting the b is less than or equal to 2 case, right? For the odd case, we sort of also reason about that, and that it just kind of comes down to the exact same problem as 2 to the 4. The negative case, I guess we didn't cover. So let's say that I have 2 to the negative 4. Right? I guess I did talk about it in that I said that negative would now be set to true. This problem becomes the exact same as 2 to the 4, except I do 1.0 over result at the very end. Yeah. Some cases to handle, I guess, would be negative. Well, I said that negative a is handled already by the multiplication. we have no invalid cases of, say, floating point numbers. If A is 0, that also works out for the multiplication. We'll just get 0 at the very end. Yeah, I think those are the main cases I can think of.
Cool, sounds good.
Okay, so power of 2 to the 4, over 2 to the 5, over 2 to the negative 4, and then let's have negative 2 to the power 3, negative 2 to the power 4, because one of these should be positive, right? So this is negative 8 versus 16. And then this similarly, oh, we already had, yeah, this one should also be 16. Oh, right, this is not supposed to be 16. This is supposed to be the other way around. It's 1 over 16. Is it okay if I run this in a calculator?
Sure.
Okay. Yeah, so it added up to the correct amount of 0.625.
Okay, so it looks like on line 42.
Oh, this is yeah. This is actually 8 instead of negative 8. So that is an error. So we had negative 2 to the 3. Let's run through that line by line. So we start off with just having negative 2 to the 3. We go down and we see that it's not divisible. So we end up having negative 2 times 2 to the power of negative 4. Okay, so that is I'm surprised that, oh no, sorry, I mixed that up. We end up having that it's it's negative 2 to the power of 2, because our b was positive. And now we see that our b is less than or equal to 2. So we end up having negative 2 multiplied by just 4, right? Strange, because now I have a negative value multiplied by a negative value. Yeah, this doesn't work out for just this case. I think I end up having to break it up into since b equals 1, in which case I would just return a, unless b is equal to 2, in which case I return a times a. This should give me a negative value instead. It does.
Cool. So why don't we write test case with a different base, just to make sure that
this works. Okay, sure.
Yeah.
So I guess try negative 3. And 0 is a pretty important one. One of the ones I missed is to the power 0, which is a different branch. So let's just say I have 3. This should return 1. This one should return 3 to the power of 4. So I have 9, 27, and 1. This one's 0. And I guess just one more test case where it's positive. Cool. Yeah, so these seem to work out.
Awesome.
So yeah, that'll be my final solution.
Cool. So let's try another problem then. So that one looks good. I'm gonna paste it in down here. So given an array, I want you to produce return the value of the maximum subarray. So a subarray is any contiguous sequence from like maybe index 3 to index 5. but you don't have to return the actual sequence, but you need to return what the maximum value is. And so once you add these pieces together. So if you look through the array on line 55, maybe you can tell me what you see as the maximum value of the subarray, and then explain to me your approach.
Yeah, so it seems like it's from 4, -1, -2, 1, and 5, which is going to sum up to say 6, 10, 7, right? Yeah, so I'm pretty sure that I've done this problem before, but I just wanted to point that out. But I don't really remember the approach, so I guess it's still valid.
Okay, I mean, I'm happy to give you another problem if you'd like, but we could also just do this one. It's up to you.
Sure. Yeah, just because I remember there was something, involving with 2 pointers and all that, right? That seems kind of familiar.
No, that's not this problem, but no.
Okay. Yeah, I was going to say we can probably go with this one because I don't think of something right off the bat, which means that it's been definitely long enough.
Yeah, the 2 pointers solution is n squared, which is not the solution for this. So right. Yeah, just go ahead and let me know what you're thinking.
Yeah. So let's try and reason how I would actually do this as a human, right? So one approach that I can kind of take for a naive solution is I would just iterate through and try to find all subarrays of length 1 to up to n, right? And I should be able to find the maximum subarray sum that way. Because these are continuous, I know that there's no blocks in between my values, right? What might be useful in order to stop me from having to repeatedly, do recalculations is I can actually notice that there should be, say, sums that I can store inside of some separate structure. How would that work out? So let's say that I have my sum between over the first value. I know that the sum that goes here is -2. And when I go from position 0 to position 1, and I have that set as my subarray, now I have -5. And I should be able to save that, saying that, say from position I to j, that's what my sum is, right? How does that help me improve from a, an n squared solution to something that's linear? It seems like if I go down this path, it doesn't. Because what I'm thinking is that for each of the values that I see at the next position, like let's say I'm at index 2 where the 4 is, I would end up checking all of the previous i's, right? But this is the exact same, even though I'm storing the sum, I'm doing the exact same logic as if I were to just enumerate through all the sets. So let's see if there's any actual structure that I can use. Queues, stacks, those are not really helpful. Seems like the only structure that would really help me is either I have an array or a 2D array. If I were to use a single array, what could I really store as data? We already talked about what happens with the 2D array, but that ends up being ultimately an n squared solution. If I were to use a 1D array, one thing that you would normally have for, let's say, like a dynamic programming approach is that I would be able to store the maximum subarray sum at some point, but I don't think that having a partial solution for that leads me towards a larger solution. Just because even if I know that the largest subarray sum at some point is some value, when I get to a later on index, I can't really use that previous information, right? Like let's say I know that over here it's -2, -5. When I get to the 4, can I really use the -5 in any way? I think so, in the sense that because I know that that value is negative, yeah, it's definitely helpful, because what I know is that because that point is negative, there is absolutely no reason that I should start from that point, right? The point that I should start from has to be something that's positive. So here, if I were to keep track of the running sums, I have 4, I have 3, I have 1, and then I have again 2, right? And then I have 6, and then I have 3. I think this is probably leading towards the linear approach that I'd want to take, because what I can say is that my start position is always going to be whatever value started off as being positive. So let's say I start off from index 0. My candidate position is always going to be, let's say it's, it's 0 to begin. But as soon as I find that I go from negative to positive, my start position should be at that index. And as soon as I go from, let's say, a higher value to a lower value, actually, now that I think about this, it almost seems like I can just return the max here, right? Yeah, it seems like I can just return the max. It doesn't seem like I need to do any other looping at all. Yeah. so I was going to give some other cases, but I guess you just agreed with that.
Yeah. No, that's definitely the right approach.
Cool. Yeah, so this ends up taking me big O of n runtime complexity and big O of n space complexity, where n is the length of the input array. So I guess is it okay if I code this?
Yeah, go ahead.
Cool. Awesome. So def maximum subarray sum, set the array. I have my sum is equal to 0, and then I have my array is equal to 0 times n, and it's going to be length of the array. All I want to do is for each of the indices in range n, in comma value, and enumerate r in loop for 8 r. I just want to increase my current sums for the value and say that solutions at end is going to equal my sums. Then I return the max of solutions. That to me seems like the correct translation of the idea I had from before, but let's just go through this example. For printing it off with, or just calling the function with this input, I'll see right off the bat, I have my initial sum is set to 0. I have a solutions array that's as long as the input array, and I start off with the 0th index. My summed is now -1 or -2. My solutions at this point is going to end up being okay. So there was a difference in what I decided to do here. I forgot to include an if. So it's supposed to be that if my value is positive and my existing summed is negative, in that case I reset, right? So if summed is less than 0 and I guess it's just if summed is less than 0, then summed is set to 0 again. There's no reason I should be including previous negative values. So my array is actually updated here, and that instead of having -2, -5, it should be -3. Because I'll start off from the 0th index. I'll set the summed at the 0th solutions index to being -2. I get to the 2nd index. I see that summed is less than 0. Again, I set the maximum possible value here to being -3. I get to the 3rd index. Now I want to set my sum to being 4, right? And again, I continue to the next place, and the rest of the logic should just repeat. And then I get 3, then 1, then 2, then 6, and 3. During none of those times, I'm going to reset summed because it never hits a negative value. And finally, I return the max that I find. So I think this is probably okay. Running it through. I should end up getting 6. Oh. Sorry, let me also comment out the previous thing. I think I got 20. I think I got 7 on this though. Is that correct?
Well, you're using the original.
Oh, yeah.
So I think 7 is the correct answer.
7 is the correct answer. Cool.
So could you show me could you write like a small suite of tests for this algorithm?
Yeah, I was just about to add some additional test cases. So one of the things that I didn't say consider was if it's all negative, and what should happen in that case is that I just pick the largest negative value, right? So okay, maybe I shouldn't put -1. Right? Well, I guess it's always going to be the max, right? I can do this the other way around just to make sure that the ordering didn't have anything to do with it. Here I should end up, again, just resetting every time, and I just want to pick the highest max value. One of the other test cases to think of is if it's an empty array. What do I really do there, right? Like, I guess in that case, I would want to do the check for that, just because otherwise I have an invalid max operation. So if array is none, or len of array is 0, just return 0. Adding that test case. And I guess the other extreme case is that I have all positive values, right? 1, 2, 3, 4, 5. Just because the first test case seems to really cover the biggest thing that you might have, right? Where you have a bunch of negative values in the middle, followed by positive values that are in a chain. One thing I could do to make this test case a bit better or more exhaustive is I could actually go negative again and then positive afterwards. So let's say I have -27 followed by 10, right? And then my final solution should actually be the 10 at the very end. Cool. So 5, 4, 3, 2, yeah, that seems to add up. It picks -1 for all the negative values. All of these test cases seem to be okay.
Okay. Yeah, it looks great. That's pretty much a typical phone screen for some of the companies I've worked at. So good job. But yeah, I guess to give you some feedback quickly. So everything overall was pretty good. I think it was good that you communicated a lot. I don't think it's always necessary to discuss the complexity of your approach before you start coding or putting some stuff down. A lot of times when people are doing phone screens or interviews, they're usually worried about running out of time or going to their next meeting or something like that. So it's worthwhile for you to like talk through the problem and then start writing down code, just in case you end up short on time. You're able to demonstrate more of what you know how to do. So that's my only thing, is to just be aware of, like, I guess you call it, it's kind of like basketball, like managing your clock. But you did really great. So yeah, good job. That's the only thing I would recommend, really.
Cool. Yeah, I guess that makes sense to me.